So I'll start with the technologies that can produce the finest feature sizes. Everybody here knows, I'm sure, that photolithography is used for semiconductor processes. It's less well known that these processes are now used to produce optics. And here are some examples. It's my understanding that this kind of a structure, that is an array of microwells, can be used to capture individual living cells for a variety of biomedical applications, as microwells for fluidic applications, other biomedical applications.
What is the scale?
The scale here, this is 134 nanometers, and I believe the scale is comparable over here, 1 to 200 nanometer. Right. So, these features of this size can only be produced by interference lithography methods. Other patterns can be produced as optical diffusers or as for anti-reflection purposes. This actually is an anti-reflection structure. The scale here is 1 micron, and this is called a moth eye pattern. And a moth eye actually has a hexagonal structure in its eye that reduces reflection to almost zero, and so this is an attempt to replicate that biological structure. And I guess of course this crosshatch pattern isn't quite as good as a hexagonal structure. It's hard to beat Mother Nature, isn't it? But that's still being worked on. So these are the polarizers that were just mentioned. This is a wire grid array, and Moxtec has patents on this technology. And this is a linear polarizer. It only passes the polarity that's orthogonal to that wire grid axis. And what's really interesting is that they can now produce not just plate polarizers with this technology, but actually pixelized polarizers with pixels going down to the 7.4 micron size range. Great technology. It's got very high spectral and angular bandwidth, decent extinction, high temperature capabilities, unlike some other polarizer technologies. And some of the applications for this are really interesting. We got involved in Moxtec several years ago when we were in the optical cancer detection business, and we were developing polarized fiber optic probes, and we wanted to collect light at the tissue of 2 different polarization angles and be able to do spectroscopy on each of those fibers independently back in a box. And so with Moxtec we developed polarizers that were as small as 1 millimeter in diameter that had these special patterns put on them that we could align over the fibers at the tissue end of the fiber, so that what was entering the 2 fibers was light of 2 orthogonal polarization states. And this can be done not just. So talk a little bit about replication. Heptagon is a global company with offices in Singapore and Switzerland and the US. And they start with a process of very accurately dispensing adhesive, then embossing the adhesive with a mask, curing it, separating it, if needed, repeating the process on the second side of this glass wafer, stacking multiple wafers, sometimes with spacers, and then dicing or singulating them to create complete wafer-level cameras. And they're achieving, micron alignment accuracies on these plates. Swiss company SUS, Micro-Optical Technologies, Microtech Lithography rather. Similar technology. Here they show a couple of variations where they have a glass stamp or a PDMS stamp, which is polydimethylsiloxane on a glass backer. They have two different ways of applying epoxy, either in one glob or precisely dispensed into multiple locations, pressed and cured onto the wafer, and they end up with two distinct architectures, one with a residual layer that can be a surface apertures or a blocking layer, and one without. And again, we're talking scales here anywhere from tens of microns up to even a few millimeters in size.
So how does that compare, for example, with optical disc technology?
Optical disc
Yes.
technology? In terms of scale?
Yes.
It's gross. Yeah, I don't know quite what the dot pitch is on Blu-ray, for example, but it's certainly okay. Then I guess you know that answer.
I think some of these techniques have been used in stamping.
Okay. Okay. And here's an image of a completed wafer level complete camera. Here you can see with 4 optical elements, a cover glass, the sensor itself, and on the back, this is generally a back thin sensor, and with silicon through vias and ball grid array on the back for electrical connectivity. And this silicon through via technology is one of the enabling technologies. I think I have another slide on that.